Hello everyone, myself Dr. TV Nagaraju. I am working as an associate professor in Department of IT, MLR Institute of Technology, Hyderabad. In this session, we are going to discuss about the life cycle of a thread. What is a thread? How the life cycle means? What is the life cycle means? Simply, a thread changes its stage during execution. That is, a thread is created, moving into ready state for execution. During execution, it meets any problems, move to some blocked state. After that, the thread is completed. That means the thread changes its state from thread creation to thread completion, or from thread creation to thread termination. We will discuss how the thread changes its states with the neat diagram. First, what is the first step? Thread creation. That means just one thread is created. We are not allocating any resources. Just thread is created. That is called new state. That is new state. Once the thread is created, and if the thread is active, that is, it is ready for running. Ready for running means ready for execution. It moves to this state, ready to run, means now the thread is ready. Whenever you are allocating the CPU, I will execute my task. Okay. Now who allocates the CPU? Thread scheduler. The name specify. Among ready to running, multiple threads are there. Among multiple threads, to which thread I need to allocate the CPU? This thread scheduler decides to which thread I need to allocate the CPU. So internally, this thread scheduler also follows two types of algorithms, by using time slicing or by using priority based. Suppose if you are using priority based, among all the ready threads, which thread has the highest priority? That thread is moved to the running state. That is for execution. Okay. Suppose if you are using time slice in the sense the entire time is divided among all the threads. So first thread 1 move to running state. Once their time is completed, that is time slice completed, again move to ready state. Second thread. So the time is distributed among the threads. So based on any one of the technique according to the requirement, the thread scheduler transfers the thread from ready to running state. Okay. Now during running, different things happen. Suppose in the running state, if my entire task is completed successfully, immediately it moves to thread completion, means the thread is completed successfully. There is no problem in the thread. Clear? There is no problem. But during execution, any event occurred. That means before completion, any event occurred, the thread is moved to blocked state. The name specifies the thread is under blocked. What are the different situations to make the thread as a blocked? So the first one is wait. Wait means the thread is waited until it receives a notify message. That means the thread is temporarily block the execution until it receives a notify message. So that particular thread enters into wait state. We discussed one example. So withdraw and deposit. Suppose I do not have sufficient amount for withdraw. I need to wait until another person deposit the amount in my account. Okay. Until deposit, I am under temporary block. That is one scenario. Second scenario is sleep. Sleep means waiting only, but on the specified amount of time. Suppose sleep of 2000 means the thread waits only 2 seconds. Once the time is completed, again blocked state to ready state. Now blocked an IO. IO means input output. That is, the thread is blocked for any input output operation. That means for completion of the thread, I need some input. Suppose for completion, I need some printer, but the printer is busy with another thread. So I need to wait. Printer is an output device. I need to wait for a mouse. You got it? For any input output operation I require, I am under waiting state. That is blocked on IO. Next one, blocked to join. That means if multiple threads are there, one thread is waiting for another thread. That means I will complete my task. I am waiting until the completion of another thread. The two threads that are interrelated. So, first thread needs to be wait until completion. That is join. Block to lock. Once we provided a lock, that is a mutual exclusion. Remaining all must be under blocked state until the lock is released. These are the different scenarios where the thread enter into blocked state. This blocked state is also called as live lock. Now, once any of this event is raised, I entered here. Once the event is completed successfully, again my thread enter into ready state. My thread enter into ready state. Clear? Now, during this, suppose I am in wait operation, but I didn't get any notify. What happened? Waiting. Simply I am moving into deadlock. What is mean by deadlock? It is a continuous blocking. Means it does not restart again. Continuous blocking. This is called deadlock. So, these are the different states. The thread move from creation to termination or creation to deadlock. Okay, this is the life cycle of a thread. Here the most important thing is thread scheduler task also plays very crucial role. Why? Multiple threads are available. Which thread you need to select? Which thread you need to select? Based on the order of selection also plays very crucial role. Generally, if you are using priority based algorithm, for example, first one thread is entered, assume thread T1 is executed. During execution, one more thread is created and it is in the ready state. Whenever thread T2 is in the ready state, immediately this algorithm checks what is the priority of the current executing thread, what is the priority of the newly coming thread. If the current priority thread execution is high, then no problem, continue. If the current priority thread is less than newly coming thread, now simply do preemption operation, that is forcibly stop the execution of current thread and moves to the ready state, and the highest priority newly coming thread enters into the running state. So the thread scheduler plays very crucial role for transferring the state changes between the threads. Now these are the things that are available in the life cycle of a thread. This is the end of today's session. Thank you.